So now, in this video, I decided to get out the handheld oscilloscope that I got there. I'm actually charging it right now. There's a USB-C that charges it. And we have the circuit here is called a non-inverting comparator circuit that I'm using an op amp for. So I made some recent videos for this. So you can see the green line is above the yellow line right there. And so we have a high output. The green line is higher than the yellow line. When I drop the green line down below the yellow line, so it's lower, we have a low output. That's why it's a non-inverting comparator. So you can see the LEDs changing right there based on whether my trim pot voltage is higher or lower than the reference voltage. Hopefully that makes sense. So yeah, this is one of the probes there. I just clipped it to a jumper to get into the spot. There's the other probe. So I use green for green and then orange for the yellowish orange right there. And then there's also an alligator clip for the ground right there. So that is our 0 volt reference point. And so put that back there. Now, that was looking at the, when it came to the orange line, our fixed resistors right there going to the inverting input. The output wants to be more like the non-inverting input than the inverting input. So we'll go back. So the orange line was at 2.5 volts right there. Now you can see it is close to 0 volts. Let's see where 0 volts is. And so it's actually higher than I thought it would be. I thought it would make it to ground pretty good. But apparently with the load, it does not. We got that blue LED lit up. And so I'm going to turn this up. Remember, we have to go to 2. So that's 2 volts there and a half. That's the halfway point before it will jump. That's where the orange line was before. Yellow line was before. So I can go anywhere above that 2.5 up to 5. But there you can see we're falling, what is that? About 2 volts short, it looks like, according to this oscilloscope right there, from the 5 volts of the supply. But it's enough to light the red LED pretty well right there. So these op amps aren't really meant to power a load. I mean, the LEDs are fine. We just need them to light up. We don't need much power. But that's really about all the power they can handle. It looks like it's struggling with the LED, but as long as the LED lights up, we are happy. So we're a higher voltage there. You can see that the output is high. It's a higher voltage at the output than when the output is low right there. Now it's down low because our signal voltage dropped below that 2.5 volts that we set for a reference voltage. So now I rewired this to be an inverting comparator. So we have our signal here. You can see it's down closer to the negative supply, even though we have 2 equal value resistors there to set half of the voltage. So this is lower. Now we have a high output. I can turn this and flip it, of course. But the purpose of this video is to look at the oscilloscope. So hopefully you got a good enough view of that. So yeah, right now we're back to that position we were at before. Our signal there is below our reference voltage. And as long as we stay down here, the output's going to stay high. And once we cross the line though, go above that line, then the output goes low. And by the way, if we hover right at the same line, we get the voltages perfectly equal, which doesn't seem to be very easy at this with the circuit. Then we would want to add hysteresis to make the signal move just a little bit so that it's never hovering at the same voltage as the signal. But we're not going to worry about that now. We're not even having that problem. So we have a higher voltage for the signal and a low output blue LED. That's going to be the same. We'll measure that. But there you can see now we are lower with our signal than our reference voltage, and we have a high output. So that's what I'm going to do. I'm going to go to the output now where the resistors for the LEDs are connected. So there you can see we got our signal down, not all the way down that we can go, but the output is high right there. It is lighting the red LED. So we're going to raise, get a higher signal voltage. Now we have a low output. So that's inverted right there. We got our blue LED. It's connecting to ground as good as it can. which is actually a volt short from ground. There you can see I can go to the trim pot all the way to ground. So I thought it would do better than it is for connecting to ground, but I guess not. So that's one reason why it's good to measure the voltages with the oscilloscope and or the multimeter, but the oscilloscope is a little easier to understand. You can especially seeing the changing voltages in instant time right there. If you set it to roll, so I haven't used the oscilloscope for a while, I can't remember what the other settings for, but when you have something going really fast, where all you would see is just a bunch of garbled, maybe like one big thick line because it's changing so quick. You can change it where it actually kind of takes like a snapshot every so often, and it will show you the form of the voltage changes over whatever period of time that you set. So, you know, like microseconds or nanoseconds or something. You can have it be like 1 microsecond across this whole thing there, and you could see like all the changes it made in that. If it changes like 10 times, you know, that's 10 changes in a microsecond. Hopefully that makes sense. But in any case, again, I should have charged this now anyways, so I'm doing that. Otherwise I can usually use it with the battery, but then the backlight, I have it set to go dark so I don't drain the battery all the way, and I think auto shut off and stuff. And it was a good time to use this, so I hope you enjoyed looking at this. I'll try to come up with more oscilloscope videos, but they don't tend to do very well, so that's why I don't make as many as I would otherwise. So thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.